Hi everyone, hope you have a great day today. We are going to go over our last section for the semester, chapter 12.5, and we're going to go over exam 4 review. And your exam will start basically tomorrow and runs until Sunday. And your final will run from the 10th to the 13th. Okay. So let's get started to our last lecture. So the binomial theorem is basically a binomial expansion. So let's see what does binomial mean. Binomial means that it is two terms. So here we have an example of an x and a y. If you have it raised to the 0 power, it's just going to equal 1. And that's true for any values other than 0. So x plus y to the first power here is just x plus y. Now you're probably used to seeing this one right here because that's just a parabola, or basically a quadratic. So you can see here x squared plus 2xy plus y squared. Now what happens here, that as the power increases, there's going to be a pattern that emerges, okay? And that pattern is called, from the coefficient of all of these terms, it's called the Pascal's triangle, okay? So I'm going to skip this right here, and I'm going to show you what is the Pascal's triangle. So the Pascal triangle is created from the coefficient of this binomial expansion. So here we have 1 on the outside, and the row below it is basically the sum of the values above the two numbers. So here, 2 is created by adding 1 plus 1 to get 2. The 3 here is created by adding 1 plus 2 to get the 3. And similarly, you can see here that all of these values below it is formed from the number right above it. So that's really interesting thing that actually shows up. And you can see here, if you continue this, so this here is to the 5th power. So now let's note how many terms are there if you're raising it to the 5th power. So there are 6 terms. This here is n, so this is the 5th power. So basically you have n plus 1 terms, okay? So let's denote that. So for a binomial with nth power, you will have n plus 1 terms. Okay. All right, so this is just the explanation of the Pascal's triangle here, and I just explained how you got these numbers here. All right, so binomial coefficient. So now we have another way in order to look at a combinations. So last time we introduced combination and permutation. Now there's some different ways of writing combination and permutation. For example, you can write NCR. So this is the normal way that we normally show that it's a combination. Now this is a different way, but it has exactly the same formula. So we have n, choose r, we have n factorial over n minus r factorial times r factorial. Normally you see this r factorial back here, but it doesn't really matter where you put it, okay? Okay, so we already did this last time, so let's take some practice on how to find out what it is. So 6 choose 2, we have 6 factorial over 6 minus 2 factorial. So I showed you before that you definitely don't want to expand all of it, because you can see here that we can cancel all of this. So the shortcut that I would show you is that you would expand until you can cancel with something in the denominator. So here I'm going to stop at 4 factorial because there's a 4 factorial at the bottom. And we can expand 2 factorial because there's nothing else to cancel with. So I can cancel the 4 factorial, and then I just have to reduce the 2 to the 6 reduced by 2. And you get the same answer, except here you don't have to waste time to expand all the way down to 1. Okay? 8 choose 0. So here and show you an important fact that remember that 0 factorial is actually equals to 1, not 0. That's a very common mistake. So we need this to work or to be true in order for factorial to exist. Okay, so here we have a factorial over a factorial, which is a equals to 1. So if you think about it, okay, in a combination, if you have 8 choices or 8 things, and you have to pick all of them, okay, how many ways can you pick all of them? Well, you can only have one way to pick all 8 because it doesn't really it doesn't matter the order that you pick it in, as long as you have 8 of those items. So therefore, you can only have one way to take all of those 8 objects. Okay, same thing here. If you have 10 and you choose 10, it still equals to 1. So this here is a way for you to calculate the Pascal's triangle. So let's look. You notice that 8 choose 0 give you 1, but 10 choose 10 is also 1. Well, if you want to say 8 choose 8, this is also 1. So that is basically saying this value is here and this value here. Okay, so that gives you the beginning and the end of your Pascal's triangle. All right. And yes, you can also use the graphing calculator or Pascal in order to evaluate combinations. Now, this is where you will see it being used. Now, for the completeness of this, okay, you can also write n choose 0 here for completeness, because that's just equal to 1. Over here, you choose n, choose n. So that's basically the formula, okay? Now, they will give you the complete formula, and I'm going to show you how to memorize this without actually having to memorize it, okay? So there is a pattern there. Okay, so we write the term value, the term number, okay, as 1, 2, 3, 4, all the way up to here. Okay. Now, if you want to deal with term number being 1, or you can actually start with the term number being 0. There's 2 different ways to look at this. Now, if you choose the term number to be 0, 1, 2, 3, all the way up to n, okay, that way you can match the R value with your term number. But the problem with that is that the book will actually tell you what is the third term. Well, the third term is this one right here, because it is the third term in this expansion. So therefore, we can't really use the term starting at 0 here, okay? We have to use the term number 1, 2, and 3, and so forth.
Hey, Professor,
Okay, so,
you just mentioned something called the R value, but that wasn't something that you mentioned earlier. Is the R value in this case also the common ratio, or is that something else?
No, R is not the common ratio. R is the value that you choose. This right here. This is R. Yeah.
Got
N
it.
choose R. So the way we read this is a N choose R. So N would be the total number of objects, and R is the number that you choose.
Okay, I understand.
Yeah. So if you have like 10 employees and you want to choose 3 of them to be in a committee, the N would be 10 and the R would be 3.
Got it.
Okay. Yeah. Okay, so let's look at the pattern here. Okay. You have X plus Y raised to the N is equals to NR X to the N. Okay, but look at how the N value is different, right? Okay, so now what I want to do is write this so that you can just basically plug in the N value and the R value into here no matter what n and r value is. Okay, so here we have x plus y. So here we have x times y. Now look at the relationship between the exponent of these x and y here and see if you can come up with a pattern. Okay, so you see there's a pattern right here. This is the same number, right? So the r value is always the same as the exponent of y. So if this is r, then this is r. If this is r, and you see there's a pattern here, n minus r, n minus r. And that is your entire formula in general. Okay? Now the term number is going to equal to, you notice here, my term number is 2, my r is 1. My term number is 3, my r is 2. So there is a direct relationship between the r and the term number. So the term number is just r plus 1. Okay, so if I want term number 10, I would use r would be 9. Okay, so r would be term number minus 1, right? Just the same relationship. All right, so you're going to see how we use this later on, but do make sure to write this down. This is important for you to determine the relationship between the r value and the term number. Okay, so let's look here. All right, we're going to use the theorem in order to expand this. Okay, now instead of doing all this here, I'm going to ask for one specific term. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see here we have 10 terms total. And I told you earlier that you're going to have n plus 1 many terms. So my n value here is 9, so I'm going to have 9 plus 1 terms. So I have 10 total terms, right? Okay, so now let's say I want to find out the 8th term. Okay. Okay, find the 8th term. So remember, this is n over r, x, y, and n minus r. Okay. Okay, so term number and r have a relationship. Okay, so the term number is always one more than the r. So if it's the 8th term, your r is going to equals to 7. My n is the degree. Here is 9. So here I'm going to use 9, choose 7. Now the r value is going to be the same for the exponent of y, and then I need 2 more to get to n, so this is going to be 2, and that will give us this here. Okay, so this is not complicated yet. It's going to get a little bit more complicated when we have different values for the binomial. Any questions so far?
No questions from me.
Okay. Okay. Yeah, so here, this is where they actually apply the formula. That's why you see all this factorials and stuff here. Okay. All right, let's do this one. Let's cover this up. Fine, so I'm gonna have you guys try this over here. Okay, Amy, you can try that one. And mine. So if you want to use the Pascal's triangle, you can go ahead, because this is only to the 5th power, so it's not that, that long to create the Pascal's triangle. But if you get something a little bit higher, like 9 or 10th, then you can always use the combination. Now, one thing I want to point out is that the Pascal's triangle is symmetric. So if you look here, right down the middle, you see how the numbers are reflective of each other, right? So what we can do, okay, is that once you get to the middle, you can always use the same number going backward. So in this line right here, in this row, you have 1, 5, 10, and then go backward 10, 5, 1, 1, 4, 6, then going backward 4, 1, and so forth. Right? So it depends if you have an even or an odd numbers in here. So you can always only have to find out half of the values and then just use reflection and going back down. Okay. All right, go ahead and give that a try.
Hey, Professor, I have a question. Oh, okay.
Yes.
Because it's negative b over 2, right? Am I to assume that there'll be alternating signs?
Yes.
Okay. Professor, do I need to simplify my answer any further
Um,
to account for the b over 2? I mean, that
yes.
denominator.
Mm-hmm. Yeah, you
So I
should
distribute
simplify
2.
all of the coefficient that you can.
Okay, I think I get it.
Okay, good job. Um, wait. How did you get this? Hey, I think you meant to be this one right here.
Oh yeah, it should be 2a instead, right? Because you're distributing the 2 to it.
What two are you doing?
Hold up. Oh, okay. So it shouldn't be 1/2 at all. It should just be a, and then it should just be negative b to the 5th.
Yeah? No, it's just a to the fifth.
Yeah, that's what I said. I said it shouldn't be 1/2 a to the 5th. It should be a to the 5th, and it should be negative b to the 5th at the end. So I got
Yes.
the beginning and the end wrong.
Yeah.
I see, because the a to the 5th didn't have a b over 2 variable as well. Okay, I see it.
You also miss. I think you multiply by 2 instead of dividing it by 2.
Isn't so? I mean, like, aren't you supposed to multiply it by 2 to get the 2 out from under the b, and then that
Oh,
multiplies it by 5?
no, 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 no. This is bad. Okay. So you have 5 times basically 1/2.
Oh, okay, I see what you mean. So you basically pull the. Okay,
1/2
okay.
out. Yeah.
All right. Well, I will rewrite. Is 5/2.
Okay, when you're free, go to the next one. I think mine's trying to finish it up here. And in the end, let's see what you should get. Uh-oh, aim. I think you miss a lot here. I don't think you followed the formula, aim.
Oh no. Okay.
How did you get 10 here? Did you do 5 times 10 here or something?
Let me see.
And then, let's see. And then you didn't square the top and bottom, so this should not be 2, it should be 4. Because it's b over 2 parentheses, so you forgot parenthesis here. And then that should be b squared over 4.
Oh, okay,
And then
okay.
this should be 8, and that should be 16. And that should be 32. So yeah, put parentheses around it.
Okay.
You did the same thing. For this one right here, you have parentheses over here, which is good, but you didn't square the top and bottom. So you did the b square right here, but this needs to be 4.
Oh, I got it. Thank you.
Just, yeah. Okay, good job, Mike. Try this one. Okay, try the next one here. So this one only goes to the fourth, but it's a little bit more complicated. So I want you to be careful when you're expanding. Make sure that you write every terms out, and don't try to take shortcut. Okay, so try to use the formula, and then apply it, and then you can simplify it, because that's where you're going to make mistakes, because there's going to be a lot of square roots and squares here that will cancel and reduce. So therefore, you should write out every terms and be careful when you're simplifying them. Okay. All right, go ahead and do this one. Are we doing it somewhere? Trying to see where you guys are.
Professor, you want us to do the one with the 3 over m squared? Is that what you mean?
Uh-huh.
Okay, okay. Hey, Professor, before I continue, can you check my math on this part where I have to have the coefficient of 4 choose 1 here, right? And then I also have to do the math of the exponents here and here to get 27 over m to the 6th.
Yeah, looks fine.
Okay, I think before I corrected myself, I forgot to do the coefficient. Okay, I understand. Thank you.
Mhm. Now, you forgot something though. You forgot to put the negative into your b value. Oh, you took it outside here.
Yeah, I took it outside already because I understand intuitively that it's going to be alternating signs between the terms. But do you
Okay.
want me to keep the negative with the b value?
Well, so here's the thing. When you have that, the result is that is because you have an odd power here. That's why it's negative.
Odd power. Can you highlight that where the odd power is? Is it
Yeah.
right here?
No, not that. This one. This number is the one that dictate whether it's going to be a positive or a negative. So if this term right here is a negative term, right, you raise it to an odd power, that means that this is going to be a minus. That's the reason why. Okay? Because if you don't think of it like this, okay, and I have you do, for example, I would switch this around and say negative 3m squared plus 2 square root of m, then
Okay.
what's going to be true?
Well, then, I mean, for me, I would intuitively think that the first term would be negative, and then it's just going to be alternating from that first term on, rather than in my original case, the first term was positive and it alternates from that term on. But
That's not
that's
true
just
either,
okay.
because it depends on what n is.
Depends on
Because
what.
if you put this term right here into here, right, the
Oh, I
first term is still going to be positive because this is to an even power.
got it. Okay,
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 but if I have it to an odd power, then this first term will be non-negative. So it
okay.
really depends on a lot of factors. So it depends on the term itself and the degree that it's raised to. So don't always think that it's going to be positive, negative, positive, negative. Okay, it really depends on what the term inside is.
Yes, sir.
So I want you to do an extra step and think of it as like, okay, this is a negative here. And then when you, on the next step, when you are simplifying all of this, then you can bring this negative to a front because this is an odd term. Because if this started out with 5 and this is 2, then that's not true, right? Because then this would be a plus instead of a minus.
Okay, I think
So
I
be
see your
careful.
point.
Yeah, so be careful.
Hey, Professor, can you check my math right here? What do I do with these numbers with the -4, the 27, and 2?
You can combine all of those.
Okay, cool. And then instead of square root of m, can I also think of this as m to the 1/2? Does that affect the 6 at all?
Hold on. You're missing something again. So what term number is this?
This is term 2 if we start indexing from 1.
Oh, this is term 2? Okay, so you should have square this. Wait, hold on. No, this is the first power. Yeah, okay. Just trying to see your work here. Yeah, remove all that.
It shouldn't be squared because it's m to the first power, right?
Yeah, so it's first, yeah. Third, 6. Yeah, okay, that's fine. So you're basically going to multiply 4 times 27 times 2.
Mm-hmm.
Yeah.
Which is going to be over m6 to the square root of m. And then my question is that can this be simplified, the square root of m and the m to the 6?
You can. There's different ways to write it. You can write it as a fraction.
Okay.
Yeah, you can probably write it because m square root of m is 1/2, and then you can bring it to the denominator, and then you can combine 6 and the 1/2.
So I see what you mean. Okay.
Yeah.
So it'd be m to the 6/2, right?
No,
Combining
that's
no 7/2. That's not that's okay. So it's gonna be m to the 6 plus m to the 1/2, which is gonna be m to the
it's minus 1/2, not plus, because you're bringing
the
it to the
square
bottom.
root. Okay.
So it'll be 5.5.
Minus 1/2, which is supposed to be m to the 5.5. 5/2. Okay.
No. 5 1/2. You have 6 minus 1/2 is 5.5.
That's what you meant. Okay, yes, sir.
So that equals to 11/2.
10, 11 halves. Okay.
Yes.
Okay. And then that's 6 times 9 times 2. That's going to be plus 1.
You have a mistakes over here. You have on your third term, this is supposed to be positive, and the reason why that's positive is because this negative right here is being squared, so that should be a plus. Okay? You see it?
Yes.
3.5.
Okay, and same thing over here. So since this is a negative, it's to the third power, so that one's okay. But this one right here is a negative to a fourth power, so this would become a plus right here.
4,
12, 24.
Okay, so go ahead and fix that.
Thank you.
24. No, this is wrong for me right here. It's not square root. It's okay. Hey, Professor.
Yes.
Right here with the square root, 2 root m to the second, because it's squared, it affects
Yeah,
that
that's
2 as well
cancel.
too, right?
Yes, so you should put parentheses around there, yeah.
Yeah, I had the
That should
okay.
be 2 square, yeah.
I see it now. Thank you, sir. So it's 6 times 9 times 4. So that is 216. 4 times 27 times 2. Okay. Yeah, that makes sense. Professor, can you check my work? I think I might be done, but this is harder than I thought.
What is this right here?
So I initially got 96 over m to the -1.
Okay, so this part right here. So when you have square root of m to the third power, this is equals to m to the 3/2 power, which is m1 1/2, right?
Oh,
Divide this
okay.
by m squared. If you bring this down here, it becomes 1 over m squared times m to the -1 1/2, which gives you m1/2.
I
So
see. Okay, I see what I messed up. Okay, because I forgot to take into account the square root.
yes,
Got it.
yeah. I think Mai got it. Good job, Mai.
Okay.
Okay, good job, Mike. There you go. Aim, you done? Looks good too. Yeah, good job. All right, so to bring us to here, we're going to find a specific term. So here they tell us that this is the R term. And so you remember the relationship between the term number and the R is that the term number is always one more than the actual R value. Okay, so here they tell us that it is the rth term. So we're going to use R minus 1. Remember, I told you before that this and this is always the same. And then this term right here, the sum of these two will always equals to n. Now, the way I write it before is a little bit cleaner, I guess. I gave you, where is it? This one. Okay. So this one is the same formula as the one below. But here, the R is the term minus 1. Okay. So here, since I'm talking about the term number, and just take R plus 1. So it's the same thing. Okay.
Okay.
Yeah. So here they asked us to find the fourth term. Okay, so let's do this one together. Okay. So if they tell you to find the fourth term, that means that the R value here have to be one less than that. So it needs to be 3. Okay. So the top number is going to be your n. So that's 10. And then your A value and B value. So I'm going to write that down first. And then this number is the same thing for this exponent. And then 3 plus what value will give me 10? So it's 7. So 3 plus 7 will equal us to this number. So there is a relationship between all of these. So that's an easy way to remember that. Okay. So let's simplify. 10 choose 3. So we have 10 factorial over 7 factorial 3 factorial times a to the 7, 2 to the third, b to the third. Okay. Now I can simplify this. So 10 times 9 times 8 times 7 factorial. I stop there. 3 times 2 times 1. And then 2 to the third is 8. B to the third. Okay. So let's simplify. The 7 factorial will go away. 3 and 9 can reduce. 2 and 8 can be reduced. And I think that's it. So 10 times 3 times 4, that's 120. A7 times 8 times b cubed. And then you multiply the 8 with the 120, give you 960 A7b to the third. Okay? All right. So now there are different ways for me to ask these type of questions. I can give you a term like this, and I will tell you what term number is this in the binomial expansion. So what you're going to look for is the second thing here, and you look at the exponent. So whatever the exponent is, you add 1, that will give you your term number. All right?
Wait. I don't think I got that. Can you go over that one more time, please?
Sure. If I were to ask you, this right here is what term number of the binomial expansion?
Okay.
So you look at this factor right here, you look at the exponent. So here this is 3. So
Okay.
that means that it's going to be the fourth term because it's going to be one more than that.
Okay, I see. Now, does that expand towards higher level polynomials, 4th power, 5th power, 6th power?
Yes.
I'm sorry. Okay.
Yeah,
So
this
if we
is
had, like,
right now, this is the 10th power here.
Yes, sir. So if we had like A7, B3, C5, right? With that C and the 5th power, it would be the 6th term of that trinomial expansion.
Okay, so no. This is only for binomial. This is not for trinomial expansion like that.
Okay, I see. So only for binomials.
Yes. So binomial have that pattern. Trinomials do not. So for b to the 3rd power here, that only works if your a and b are in first degree or to the first power. It will not work if we have a problem that was like this that we did up here with the square root and the square. That will not work because, as you can see, after you finish everything, it's very difficult for you to determine what is the a term and what is the b term. Okay, so this only works if this is nice and simple like this.
Okay.
Okay, if not, then you have to work all of it. You have to expand it using this here. Okay, now I'm going to make up one. Let's see. Let's do square root of 2 5 square root of 2 x square minus, I don't know, square root of 3 y. Let's do square root of y. To the 12th power, and I want to find the 7th term. To be more precise, I want you to find the coefficient of the 7th term. All right, go.
Okay, that's weird. Whatever.
Whoa. Why is there an addition here?
Because on the sixth term, that negative becomes a positive, right?
Yeah.
Because on the sixth.
So that's a positive. That means it's a positive number. It goes to the front. You don't add that. That's not an addition sign. All of this is being multiplied together.
Oh,
You
yeah.
know that,
Okay.
right? So
Right.
this should not be there, right? This was from here, right?
Yes,
That
sir.
should only be a one-time thing. So you need to get rid of all of this and then
Okay.
simplify. So multiply these two together and then divide by this, and then you'll be done.
Okay. So I see. They're not separate terms, they were multiplying by each other.
Mm-hmm.
Okay, so then it would be 115500000 x12 over y to the third. And then if you want me to, I should separate the coefficients, right? So it would be that number times to y to the third. And this would be your answer for the coefficients.
Yes. Did you multiply 308? Well, what is this 308 here? You didn't divide by 27 yet, did you?
Okay.
Uh-huh.
So times 12500 divided by 27.
Okay, so let's start with a review. Okay, so the majority of the tests will be about writing equations. Okay, writing equation of conic sections, where I will give you a piece of information, whether it would be like a vertex or a foci or A value, B value, whatever. So I'm going to give you a piece of information and you need to be able to write the equation of that conic section. Okay. So let's see. I'm going to look at the test right now. It's 36 questions on the exam. I had to give a little bit more because I have to add 8.4 and 8.5 in there. Okay, so basically, we want to look at examples where I'll give you, for example, let's do a quick and easy one. Find the equation of a circle with center at -3, 5 and passes through point. Aim give me a point, a random point.
-1, 8.
Okay. All right, so now the first step we should do is to plot these. Now, this is going to be true for every conic section that you do. You need to plot these points so that you can see the orientation. Now, if you were to do an ellipse, you need to know which one is the major and the minor axis. If you need to do the parabola, you need to know whether the parabola open up, down, left, right, or hyperbola, same thing. So it's always a good idea to plot these points out so you get your orientations. So -3 and 5. So -3, 1, 2, 3, 4, 5. -1 and 8. So 5, 6, 7, 8. So 1 and 8. So right here. All right, so now we know that this is the center. We know I have to cross to this point. So basically, this is a circle like this. Oh, that's not very good. Let's see if I can. Okay. So now what we know is that this point from here to here is going to be our radius. Okay. So when we write our equation, so we always write down what is the general equation of the conic section is. So x minus h squared plus y minus k squared equals to r squared. So what do we need to know in order to write our equation? We need to know hk and we need to know what r is equal to. Well, hk is already given to you here, so that's the easy part. Now r can also be easy to find because here you already have the distance from this point to this point. So all you have to do is find out what is the distance here, and you can use a distance formula to do that because you have 2 points. Okay, so it's that easy. Okay, now I mean you can plug it in here and find a distance formula, which is nothing more than Pythagorean theorem. Okay, so that's an idea of how to approach these type of questions, and you're gonna have to do this a lot. I think that's like 10 or 15 questions like this. Okay, they ask different things, but essentially it boils down to, do you understand how to put together pieces of information so that you have an equation that you can use? Okay. All right. And of course, be able to recognize by looking at the standard form whether you have what kind of conic section you're going to have. So here, if I just look at number 1, can you tell me what shape this is? What conic section is it?
It is going to be a parabola.
Because?
Because only one of the terms are squared, y squared.
Exactly, that's correct. What about number 2? Mai, can you tell me what shape that is? Mai, you still here?
Yes.
Okay. Can you tell me example 2, what conic section that is?
Is circle?
A circle?
I think so.
Uh-huh. Why do you think so? Why is it not an ellipse? Because those two are kind of similar together.
The number of x and y is similar. Number 3.
Yes, it's the same. Yeah, very good. So if you have the coefficient of x squared and y squared be different, then you're going to have an ellipse. But since they are the same, we're going to have a circle. Very good.
Professor, can you expand on when it isn't a circle but a point, or when there's no graph? It's when the signs
Yes.
of the left side and the signs of the right side don't match, right?
Say that again.
So the left side of the equation, if that was a negative, and then the right side, if it was a positive 12, because the signs don't match, then that means there's no graph, right?
Oh, you're talking about this right here. If that was
Yes,
a
sir.
negative, does that mean that it's going to be not a circle or no circle at all or whatever?
Yeah, because that was asked on the homework multiple times.
That's not true. Okay, so here's where it is true. In this form, you cannot determine whether this graph will give you a circle, a point, or no solution. Because in standard form, we don't know what is the value on the other side before we complete the square. So in order to do that, we have to complete the square first, because remember that when we complete the square, we're going to have extra constant here that we're going to add on to the other side, which will make this either positive or negative. We don't know that until we actually complete the square. So let's
Got
do
it.
that problem. And I want you to complete the square and write number 2 in standard form, in graphing form. So this is going to be a circle, right? So we have x minus h squared plus y minus k squared equals r squared. So once you have this right here, this is the number that you're going to look at. This here is not r squared, okay?
Okay, so
Right.
you want us to complete the squares first?
Yes, complete the square first and write it in this form. Once you put it in that form, it'll be easy to determine what it is.
Oh, why am I doing red? I did the math wrong somewhere. Divided by 2, 2 squared is 4. Divided by 2, 1. Right here. Divide by 2 is 1. 1 squared is 1. this is going to be plus 3. There we go. 15, 16 plus 12. So
Why are you dividing by 16?
did you want me to get r squared to equal to 1, or did you want me to just leave it at that number first?
No, r squared is not 1. Remember that this is a circle, not an ellipse, so you don't divide that by. So this is why we know this is a circle, because these two values are the same. If these two values are not the same, then we're going to get an ellipse. So we're going to divide both of them by 3. So both sides by 3. Now that becomes your r squared. So that means r is equal to square root of 16 over 3.
Okay. And then at this form, right, at this circular form, we know that this side is positive and this side is also positive, and therefore there has to be a graph.
Yeah, it's going to be a circle.
Yes, sir.
So if this is equal to 0, then you have a point.
If it's
this here is negative, then you have no solution.
Okay. Okay. So let's see. To reiterate why I don't divide the left side by 16 is because these coefficients are the same.
Yes.
If this was a 4, just hypothetically, right, then I know that it would be an ellipse, not a circle, and therefore I have to adjust this in order to make it equal to 1 for it to meet the standard form for an ellipse.
Mm-hmm.
Okay, I think I get it.
Okay, let's continue. All right, so this is just a review on eccentricity. So make sure you memorize that. I will ask about eccentricity in the handwritten portion.
Can you go over the eccentricity? I was going to go over it with your old lecture this morning, but I was still stuck on doing homework. I don't think we were asked about eccentricity during the online homework, so I didn't really get into an in-depth study of it, sir.
Okay. Well, eccentricity is just a relationship between C and A. That's pretty much it. So if you take C divided by A, that will give you eccentricity. Now, this is another way to determine if we're going to have a circle, parabola, ellipse, or hyperbola because of that relationship. Okay? So if the eccentricity, I tell you that the eccentricity is 0, then you know that we're going to have a circle. If it's 1, we have a parabola. But if it's anything else, it could be an ellipse or a hyperbola.
Okay.
Okay? Yeah.
Thank you.
Pretty much it. Okay. So here are some practice on how to sketch this or write out the equation if I give you eccentricity and one more piece of information. Okay, so you want to practice this. Now I highly suggest you sketch these. Okay, always sketch these. So here they tell you that E is 1. Well, automatically you should think of that's a parabola because my eccentricity is 1. You get a parabola. And the focus here is 0, 8. Now, they also tell you that the center is at the origin. All right, so where is 0, 8? So let's say this is right here is 8. So we're going to have a parabola. Okay, and now the center is at the origin.
Okay, I see.
Mm-hmm.
So this means that the major axis is parallel to the y-axis.
Yes.
Okay. And we know that because it's 0, 8, it's going to open up.
Yep.
Okay.
That's it. And then, of course, you can sketch your directrix down here, too.
And the directrix will be the same length as from the origin to the focus.
Yeah, from the vertex. From the vertex to the focus.
The vertex. Okay, yes, sir. The vertex to the focus. What happens? I mean, like in this case, right? If you wanted to, how do you say it? Nudge us to a challenge, instead of saying the focus is 0, 8. If you said the directrix was at 0, -8, it would come up to the same graph, right?
Yeah, exactly.
Okay, I see.
Yeah, because they're opposite each other.
Got it. Got it. Can we go over the practice where we do a hyperbola and drawing these boxes? Because it's been quite a few weeks with the holiday break.
Yeah. So yeah, let's do it. We have one right here. So we have vertices 0 plus or minus 6. Let's go over here. Actually, let me get our graph in here. I want to draw one. Where is it? Okay. All right, here we go. Okay, vertices are 0 and plus or minus 6. So we got one right here. Oh, sorry.
It'd be on the y-axis, right? So
yeah. It's
there,
up here.
right there.
Yeah.
Okay.
And then tell you the asymptotes. So basically, these are the diagonal lines. And since we know that the center is at the origin, we know that's going to pass through here. 1/2. So 1/2 and -1/2. Okay. So since we know what is the asymptotes, this is basically the slope by using A and B. Okay. We have a vertex right here. So we're going to follow this line. Oh, wait. Guess we can make this longer.
Okay.
This very crude drawing here. Yeah, so the purpose of drawing the box is to get these asymptotes. Since here they already give it to us, and we don't need that box.
Can you? I'm gonna write it out, and I want you to see if my understanding is right or wrong, sir. But I think I just need a reinforcement of the points A, B's, and C's. So.
Okay.
Gosh. Here. Is that going to be A? And then C, let's say there was a focus here and a focus here. This would have been C. And then B is gosh, is it a ratio, or B can be a ratio?
Pythagorean theorem. It's Pythagorean theorem. A squared plus B squared is equal to C squared.
Okay. Graphically though, where could B be represented in this graph though, sir?
It's right here.
Oh yeah.
So this is A, right? So this value right here would be B, and then C would be the diagonal right here.
Got it. Okay, I was having some kind of.
Yeah.
Okay.
So this box would go all the way out here.
Well, what if you were trying to give us a trick questions, and instead of giving us A, B, or C, you give us something called the diameter or
No,
whatever, sir?
no, not that mean.
I mean, I expect the best, but I prepare for the worst, sir.
If we're face to face, I would probably can pull that. But on here, I'm just picking questions from the homework, so
Yes,
so
sir.
I don't
Okay,
get complaints. Okay.
I understand, sir. Um, how else could I better prepare for this hyperbola situation? When is a hyperbola? When is a hyperbola like this? I scroll down, sir. Scroll down. I wrote.
Oh, okay. So remember that a hyperbola, that means that one of them is going to be negative, like one of the x squared or the y squared. Remember in standard form, you have x squared plus blah 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 minus y squared plus blah 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 equals to a constant. Well, if this is a negative, that tells you which way it opens. So basically, if it opens, whichever is the positive one, that's the axis that have the axis of symmetry. So.
And then I'm as I was doing my review for this test, right? The word axis of symmetry, when in regards to hyperbolas, is confusing to me. Can you reinforce that, please?
It's this right here. It basically divides it in half, where you can fold it like this. Not like this, fold it like this. So
Oh,
axis
okay.
of symmetry would be this one right here.
Okay,
Because
so
when you're talking about parabola, axis of symmetry is this, right? So it's similar to what you're thinking of hyperbola. So it's the same thing. You cut
okay.
the parabola in half or cut the hyperbola in half this way, not this way.
So to reinforce it, right? Whichever square term is positive, that's where the axis of symmetry is.
Hmm.
Okay, and whichever one is negative, well, we just look for the positives. Just look for the positives.
Yeah, just stick with the positive. Yeah.
Yes, sir. Yes, sir. Okay, I think that's good for this section. On your review page, you said page 588 is a great review. Is that still applicable to our current text?
Yeah. Let me look. Let me double check real quick. It should still be the same because we're using the same version book here. So I mean the same edition.
Awesome.
They changed a little bit here and there. Yeah, page 588. So yeah, we would definitely review all those.
Okay. Okay.
Yeah. So on 588, actually just I'll use my I'll link that here. Not link it, but I'll show it here. So this one gives you a review of everything that you saw so far. And so this is what you are asking for, right? So you see here, this is x squared. Oh, you don't see my mouse here. But yeah, right here it has x squared minus y squared. Oh, right here. Oh, there you go.
Okay.
So you see this part right here. So you see the axis of symmetry is along the x. So that's positive is x.
Awesome. I have a quick question regarding the test. So I know you said there was 36 questions, and I know that we established there's going to be 3 hours plus a drawing component. But I know that in the past, the test that I had drawing components, right? Like I struggled to finish it on time with only 30 questions, with 6 extra questions, and with only still 3 hours. Um,
Okay, I can give
are you
you more.
saying that there's going to be like is it going to be easier questions out of those 36 questions, or am I going to just
I
expect to not do some
think it would be
questions?
easier, but I mean, I don't mind giving you an extra half hour. That's fine.
Awesome, thank you, sir. So 3.5 hours for this test.
I'll change it right now.
Awesome, thank you, sir. And for this is just chapters 8 and chapters 12. Okay. Find You said the majority of the test will be about conics, though, right? And so only a minority will be from chapter 12. Of those chapter 12 questions, for me, my expectation is the biggest time sink would be the things that we just covered today, the binomial expansion.
Yeah, the sequence stuff should be easy. That's why I said, I mean, you don't need 3.5 hours, because sequence problems should only take you a minute to 2 minutes. So I'm looking at like the estimated time for each question, and it's basically, let's see, the estimated time to finish this is 78 minutes and 57 seconds, basically 79 minutes.
Yeah, but that's if you just got out of high school and you're young and your brain is still expanding. I'm an old man, sir.
Well, they give you an estimate of all this, and a lot of these questions only takes 1 to 2 minutes to do.
Okay.
Like finding the sum of an infinite geometric series, or finding the first 5 terms of an arithmetic sequence. If you know how to add, a couple of numbers, you should not take more than 30 seconds to do that problem.
Are we going to expect at least a sizable amount of permutation and combination problems?
Let's see. I gave you only 3.
Okay, that's fine.
So 3 from chapter 12.4, 3 from chapter 12.5.
Yes, sir.
6 from chapter 12.3, because they're so short. So that's why I gotta give you more. And then the rest of those are all chapter. Let's see. That's chapter 12.1 to 3 from 12.1. And then there are 20 from chapter 8.1, 8.2, and 8.3.
Understood, sir. Can I ask you some concept questions from chapters 12 then? I'm going through my homework right now, and I'm just trying to correlate to our review sheet. I'd like to ask you about the nature of the common ratio R. Now, the homework, the way that they said it is you have to compare R in between -1 to +1. But in your lectures, you use the absolute value of R when making comparisons.
Yeah.
Is there any kind of explicit difference, or they're the same, right?
That's the same thing. Yeah.
Okay, and then the comparison of R is meant to understand whether the series will converge or diverge, correct?
Say that again.
Looking at R and whether the absolute value is less than 1 or greater than 1 is meant to derive, or is meant to understand whether that series will converge or diverge towards infinity.
Yes.
Got it. Okay, let's see what's next. Let's see what's next. Okay, and then I mean I have to. I'm just spitballing right now. The sum of a finite series and the sum of an infinite series are very much different. Okay, yeah, that's correct. Keep going. What else is there? 12.5. What's going on here? Can you? Okay, let me pull up my homework. This is 12.3, number 23. 12.3. 0.23. What number is that? 0.33. Can we go over homework 12.3 number 6, and I can read you the questions in case our variables are different?
Okay.
Okay, so it's find A1 and R for the following geometric series. A3 equals 35. A7 equals 0.0035.
0.0035?
Yes, sir.
Okay. Let me share the screen here. Okay, so can you look at that and see if I wrote down correctly?
Yes, sir. Give me 1 second. That is correct, sir.
Okay, so A3 is 35, A7 is 0.0035. And you
that
want
is
to
correct,
know
sir.
Okay. So since this is an R, then I know that we're going to have AN is equals to A1 R to the n minus 1. That's the general form of a geometric sequence, right? So basically what they give us here is basically a point. So here, this is 3 and 35, and this is 7 and 0.0035, okay? So with these two values, I can basically set up a system of equation and be able to figure out what it is. So this first value here is n. This here is an. So this is just like saying x and y, right? So I'm going to plug it in here. So here I'm going to plug in 35 equals to a1 r to the n minus 1. N here is 3 minus 1. So you notice we have two variables here. So I cannot solve for this without having another equation. That's where the second one comes in. So we have 0.0035 equals to a1 r to the 7 minus 1. So we can simplify this a little bit. 7 minus 1 here is 6, right? So I'm just going to erase that so I don't have to rewrite this again. So that's 6 and that's 2.
Okay, I think I see what you're doing.
Yeah. So now you just solve for one of the variable. Here I'm going to solve for a1. So a1 is going to equals 35 divided by r squared. And I'm going to plug it into here. And now you can solve for r. Okay, so now you have 35 over r squared times r6. Well, you can cancel this. Give you r to the 4th. Divide both sides by 35. And then take the 4th root of that. So r is equals to the 4th root of this, 0.0035 over 35, whatever that is.
And then my question is, because this is a geometric series, how can r be both positive and negative?
This here is a sequence. This is not a series.
A sequence, okay.
Yeah. So what was your question then?
So for a sequence, r can be positive and negative, right? Because you're taking the 4th root. So you're taking the 4th root, so there has to be both a positive and negative answer. It's I think 1/10 or 0.1 in this case.
Oh, no. Okay, you're thinking of applying. This is okay, hold on. Let me find out what this is real quick. Okay, this is 0.1. So r is equals to 0.1. Okay. So you are thinking of because I am taking the 4th root on both sides, you need to have a plus or minus here.
Mm-hmm.
I just see.
Because when I tried to solve it using how you did it, right, I got the 0.1, and then I entered the answer into the homework system, and it said it was wrong, and it took me forever to go through my math and see where I was wrong, and it's because I didn't have a negative answer. They wanted me to give an answer where it was both 0.1 and negative 0.1.
Ah, I see.
And I just didn't understand why, because I'm just an old man.
Well, it satisfies the requirements of it being positive if you plug it in here, because this is going to alternate. So all of the odd n value is going to be positive, and all of the even values are going to be negative. So this will give us two different sequence. One is an alternating, and the other one is not. Now
Okay,
that's
so,
going to give us, that's going to give us a different sum. Okay.
Okay.
Yeah. And this is 12 point what now?
12.3, question 6, I think.
Okay.
Yes, sir. Question 6.
Too cool. Okay. And then from there, you can find out what A1 is by plugging it in.
Yes, sir. I seem to be erroneously interchanging the terms sequence and series. Can you hammer out the difference for me really quickly?
Sure. So a sequence is a progression of numbers, whereas a series is the sum of finitely many numbers or infinitely many numbers. So for example, a sequence is say A1, comma, A2, comma, A3, comma, A4, so forth. So each one of these is a number. A series is basically S1, S2, S3, but notice that each one of this itself is a sum of finitely many values here. So a series itself is actually a sequence composed of the sum of these terms, right? Because S1 is basically A1, S2 is A1 plus A2, S3 A1 plus A2 plus A3, and so forth.
Yes, sir.
Okay? A series is a summation. So you can use each one of these and call that a series. But if I write it right here, this is a sequence of this series. Kind of confusing, right?
It's a sequence of the series. Okay, I think I get it. Yeah, I mean, just when I'm doing math, right, I've learned that you have to be very vigorous in the terms that you use because math is a very precise language.
Yeah.
Can we look at the expansion of summations? It was on homework 12 too. And I know that you kind of covered it pretty quickly, but the homework itself had some kind of explanations that I didn't understand. So
Okay.
let me find it.
12.2, you say?
Yes, sir, 12.2.
Okay, what problem?
I'm getting there. 1 second, please. It's always different with a 12.2. This is 39. That's wrong. Let's do 18. 63. We are looking at number 20 to evaluate the sum of -8 minus 6i, and the summation goes from 4 to 12. And I know that you warned us because the index starts at 4, right? We have to be careful since it doesn't start at 1.
4 to 12?
Yes, sir.
Okay.
Let's.
And what's your question?
Okay, so for this one, right, I basically expanded it as a series that goes from 1 to 12 minus a series that goes from 1 to 3.
Yeah.
But the way that the homework did it is
Just expand it all.
no, they use a term, they defined A1 equals P times M, and then AN equals P times the amount of M times N. And I just didn't understand what they were doing there.
Say that again. Or why don't you write it in here?
Yes, sir. Let's see, where are we? So, I mean, I'm not sure how accurate I have. I wrote this down really late at night, but let's see. They defined how to find A1 as P times M, and then AN as P times M times N. And I was just confused as to what they were doing here. I mean, I think they were trying to do it in a way that I didn't have to expand it out fully, but I just didn't know what's going on.
Okay, give me a second. Let me see. Oh, okay. So what they're doing here is I think you forgot something here. A1 is supposed to be P plus M, not P times. And then
Okay.
the other one should be P plus M times N, because this is an arithmetic sequence, so it's basically a line. Think of this as like y equals mx plus p. Okay.
Mm-hmm.
So if you think about the slope, okay, so this right here, y equals mx plus b. So b is like your initial value that you want to add, and then your m is your slope. So you're multiplying it by how many there is, okay, by how many times you go up, because this is just nothing more than just a straight line, okay. So your p value here, think of that as like your b value, and then this right here, because this, remember that a sequence where the n starts at 1, so you don't start at the y-intercept here, you actually start at this right here. So this is 1, 2, 3, whatever. So So your first point is actually this point right here, not this point, not the y-intercept.
Okay.
So if you take the y-intercept and plus this, you get this first point here at the one location. Okay, and then whatever the end location is, the last one here, you just multiply it because it's, again, this is a linear function. So you end up with here. Does that kind of make sense?
It does, but I just don't understand how it's being applied to this specific problem.
Okay.
Because I mean, I was going to draw out, like, you know, I was going to write out like what I did, and it's basically me, like I said, splitting it into two different series and subtracting we'll call it subtracting those series.
Yeah, so that, I think that would be the quick way of doing it. I think when they are trying to explain it using the formula, it kind of make it much harder to understand.
Interesting. Okay, that's fine, sir. I mean, I think I've mastered this concept really. So if I don't need anything harder to understand at this point,
Yeah.
I had a theoretical question for you. When you have I think it's a series. When you have a series, what am I doing? When you have a series that goes I equals 1 and it goes
By the
to
way, when they're doing this right here, all they're doing is they're just plugging in this number and this number. I hope you know that.
I
Yeah, they're just plugging in this number and then they're plugging in this number to find n.
Okay.
So the p here would be -8 and the m here would be -6. And then you plug in 1 here. And then for n, you plug in 12 here. Oh, not 1, I'm sorry, 4 here.
Oh, yep. Okay. That completely makes sense because you're just finding the point. You're finding one term number in that series given the index and given the end.
Yeah.
Got it. My question was, when you have a series where the constant is being raised by the index number, right? In this case, as I was doing the homework, I discovered that if this was a geometric series, I hope that's the right answer, then the C is also the common ratio. Is that always true?
Yeah, because you have the general form a1 to a1 r to the n minus 1. So this is exactly the same form as this, where you can rewrite this as c times c to the I minus 1. That's the same thing. C is your r value.
Ah, okay. Oof, wow. Okay, great.
I mean, they just use a different letter, so.
Yes. Cool. I'm glad we got that out of the way. Let's see. Going back. What else? Let's go. We did that. Cool. We did that. So we did that. That's the expansion. How when we're expanding series, right? I know that you had to memorize. What can I draw? Oh, my app's frozen. You had to memorize the sum of like n1. I'm sorry, sum of I to the first, sum of I to the second, sum of I to the third, and that yielded like n times m plus 1 over 2, n times n plus 1 times 2n plus 1.
This one, I won't ask you that, so you can forego that.
Awesome. Okay, cool. Let's see. What else are we going through here? I've just been like trying to be really meticulous with our homework review, flashcards, and see that. We discussed that review. Okay, we talked about convergence. We talked about parabola. Okay, I'm hitting chapter 8 homework, and I don't have any questions about chapter 8. So, is there anything that we need to cover on the review sheet that I haven't done already with my inane questions?
I think you cover more than what I covered, but yeah. Do you have any questions? Don't let AIM talk you off.
Yeah, I'm just a hogger. I hog his time.
She's quiet.
She is. It's because, she knows all this. unlike me. For the permutations and combination problems, are they going to be like word problems where you tell us that there's a deck of
Yes.
cards, or okay, marbles and whatever, 3 red, 1 blue, or whatever?
Ooh, speaking of which, there is one hard question that I think we didn't cover,
Okay.
but that's the kind of question where I want you to use what you know and then be able to extrapolate from that in order to apply it.
Professor, I've
But
been taught that in statistics, extrapolation is dangerous.
nah, only if you go too far.
Okay.
Yeah,
Okay, so
but
what
if
kind
you
of
stick around to it, then you'll be fine.
Yes, sir. So, can you give us maybe like an example of that
Right.
hard question?
So let's say if I have um, 10 blue marbles, 5 green, and 7 red. Okay. All right. So in total, we have 22 marbles. Now, I want you to say how many ways can I select, um, let's say 5 marbles total. And let's say part A here have must include 2 blue
Mm-hmm.
and 3 red. How would you do that?
Give me 1 second. So I need to select 5 marbles total, and then can you repeat part A with the 2 blue, 3 red? What does that mean?
So that I want 2 blue, exactly 2 blue, and exactly 3 red marbles. That makes 5, right?
Oh, okay.
So how many ways can I choose to get that? 2 blue and 3 red. And then
Okay,
instead
so
we will talk about the probability of you choosing 2 blue and 3 red. But we won't do that here. How many
how
different
many
ways?
ways? It's interesting. I think I would do 2 combination problems where out of 22 total marbles, I choose 2.
See, now tell me what you think that give you. Restate what you just said.
Out of 22 possible marbles in the bag, I choose to. It doesn't give me 2 blue marbles, it just gives me 2
Exactly.
marbles.
That's the
So,
problem. If you are
oh,
choosing 2 blue out of the 22 total, that will not guarantee you that you're going to have 2 blue. So you can't do that. This is what the common mistake is.
got it.
So how do I certain that I'm going to have 2 blue? I have to think about reach into a bag and only having blue marbles in that bag. That will guarantee that I'm going to get 2 blue if I'm going to pick 2 marbles out.
Okay. So only reaching into a bag that has blue marbles.
I'm going to take out 2. But how many different ways can I do that? Is that a permutation or a combination?
It's a combination because order doesn't matter on when you choose one blue
Right.
marble over the other.
Right.
But then is it really 2 out of 10 blue marbles you're choosing 2?
Yeah. So 10 choose 2. So that would be 10 C2.
Okay.
Okay. So that's for the blue one. And then similarly for the red one, I have
The
7 or I choose 3. Now what do you
okay.
do with these 2 numbers?
The fundamental counting says that you multiply it.
Exactly. So you multiply. So this part right here gives me 10 factorial over 8 factorial, 2 factorial
Mm-hmm.
times 7 factorial,
3
3
factorial
factorial,
times
4
4
factorial.
total. Mm-hmm.
Right. Okay. So this gives me 10 times 9 times 8 factorial. That cancel with that. 2 times 1. 7, 6, 5, 4. Cancel with this 4.
3 times
3,
2
2,
times 1.
1.
Mm-hmm.
3 and 2 gives 6. So this here give me 35.
Plus 4.
2 and 10 here is 5. So that's 45. So you get 45 times 35.
35. Okay. So this only works, this setup only works if you had bags where the colors were separated.
No.
No? No, because like when I was doing it initially, right, like I thought all the marbles were in one bag, but that's a probability, that's a statistics problem, not a
That's the
pre-calc
probability.
problem.
Yes.
Okay, so here the assumption is that, when I'm choosing the blue, it's out of a bag of blue marbles. When I'm choosing a red, it's out of a bag of red marbles.
So now, since you're curious, now we can talk about what is the probability that you choose 2 blue and 2 red from a bag of that marbles that have 22 marbles and all these right here.
Mm-hmm.
Now that we need to talk about how many ways can you choose 5 marbles from a bag of 22 marbles.
Oh, okay.
Now, this will give you basically the total number that you can choose. So this would be 22. You want to choose 5.
Okay. But in this setup, right, 22C5, it doesn't necessarily mean they're two blue and two red. It's just how
No,
many ways you
this
can choose
is how
five
many ways
marbles.
you can pick 5. Doesn't matter
Mm-hmm.
what color, what it is. I don't care what it is. It's just a total number of ways you can choose that. So now we can do that, right? So let's see, what do you got? 22, 21, 20. Whew, that's going to take a while, right?
Up to
So this is,
17.
yeah. So it's going to be a large number. I'm just going to plug this to the calculator.
Yeah.
So let's see, 22, choose 5. It's going to be a big number. Let's see, 26,334.
Okay. Better than the
That
Texas
would be your
lottery, but still.
denominator, right? And this would be your numerator. Put them together. So 1540 divided by 26,334. So that will give you the probability. So let's see. 1,
Yeah.
yeah,
Got it. I
divided by.
see. I see the process.
So that gives you a 5.8% chance of picking exactly 2 blue and 3 red marbles. So not very
Got it.
good, but still it's not 0. Okay.
And so how extensive would this hard problem be on our test this weekend? Would you cut it off at 1540, or would you expect us to go towards and solve for 5.8%?
No, no, no. You would stop at 1540.
Okay,
Yeah,
cool.
the 5.8 deals with probability, which we didn't cover. So
Yes, sir. Yes, sir. Before I let you go, I know how long the test is. I know there's 36 questions. I know there's 2 written ones. As you've graciously allowed us to do for the last test, all these last tests, once we submit the test and once we review our results and then review our worksheets, right? If we find anything that we think merits credit, we can still email you for it.
of course,
Cool, awesome. Um, Will you extend that to the final exam too?
the final, yeah, the final. You only have, I think, 1 or 2 days to do that. Yeah.
Okay.
So for the 6th, I mean, I'll give you until for this last exam, I'll give you until the 13th, which is the day of the final.
Mm-mm.
And then on the for the final, I'll give you until actually I can only give you on Monday. So look it over right away and then tell me as soon
Awesome.
as possible because I need to submit grades. Okay.
Awesome. Thank you, sir.
Yep.
Okay, well, I mean, this is it. Words of wisdom.
Nice know. Nice knowing ya.
Thank you, sir. Thank you for your patience. I'm sorry that I was such a student. I don't know what else I could say,
No,
but I
it was
appreciate
nice having you here because I got really lonely without you here.
it.
So I talked to you. Nice to
All right.
fight.
Thank you, sir. And thank you for the test review. Thank you for the homework review. I really appreciate it. And have a happy holidays.
Thanks. You too. Take
All right.
care.
Goodbye.
Bye.